Now we're live. So we're back to here. We're looking at taking the derivative of e to some power, or what's called an exponential function. And we're going to do exactly the same thing on, let me do one more here. Let me put one on the side. F of x equals e to the x squared plus 3x. Logan, you want to take a shot at it? Okay. I'll give you a hint. It's got e in it. Two, 2x plus 3, like that, times, what do I have for an exponent? X squared plus 3x. Now, some people may write it like this. And you're done, right? Just like that. Zach, I'm going to give you a little help here. I'm going to rewrite this. It's going to be e negative 3x to the negative 1 power. Do you see where the negative 1 power came from? Okay, I got to turn this a little bit. All right, give me the derivative. Well, what I'm going to do, I think you're saying the right thing. I'm going to put a little different order. I'm going to write this first because that's guaranteed to be in there. And then you're taking the derivative of the exponent, correct? And you took a negative 1 times a negative 3 and got a positive 3. And then this x is also going to be part of the derivative, correct? And what power will it be? Negative 2. So more than likely, you'll see it look like this in your homework. 3e to the negative 3x to the negative 1 power over x squared. Do you see where I get the x squared? Or you might see it like this. Where this is written in its original form. Okay? Cooper, I'm going to give you a little help on this one. I'm going to rewrite this as the e of the x over 2 minus e to the negative x over 2, because they have a common denominator of 2. Are you okay with that? Okay. And then I'm going to rewrite it even further like this. 1/2 e to the x minus 1/2 e to the negative x. Are you okay with that? So you know what coefficient is in front of here. Okay? All right? Well, are you ready to take the derivative? What's the derivative of 1/2 e to the x? It's exactly the same thing. It doesn't change at all. What about this one? Does it change?
Yeah, it just becomes positive, right?
Becomes plus 1/2 e to the negative x. Do people agree with that? So my guess is you'll see this as an answer. I like taking the derivative of e to the x. because it's just going to be whatever that function is times the derivative of the exponent. Nathan, you're up the bat. You ready? Next page. So now we're going to do the antiderivative. So this is a derivative, correct? This thing in here. Somebody did something and came up with that answer. Because of the chain rule, what has to be here? A 3. So if I put a 3 in here, I've got to have what out front? 1/3. So my answer is going to be, what do you think, Nathan?
1/3 e to the 3x plus 1
And for 5/10 of a point,
plus c.
plus c. Because that's what it is Monday. Now I can check. 1/3 e to the 3x plus 1. I'm taking the derivative now. 1/3 e to the 3x plus 1 times 3, and that's gone. The 1/3 and the 3 would become the 1 that's in front of here. I'm going to put one like this, Rayanne. Okay, so I'm creating a new one. Oh, before I do that, Rayanne, I want to talk about one thing. I want to come back to this one. You could use substitution. So I'm going to do substitution here. I'm going to say u is equal to that exponent, 3x plus 1. So that means du dx would equal 3. That means du is equal to 3 dx. I don't have a 3 dx, do I? I just have a dx. So I could say that's 1/3 du equals dx. So now I could say I have e to the u times 1/3 du. So I can bring that 1/3 because it's a constant and I'm multiplying out front. The antiderivative of e of the u is e of the u. I have a 1/3 here. I have my plus c. Now I go back and I get rid of the u and I replace it with 3x plus 1 plus c. Okay, so that's what it looks like using u substitution. Now, the reason I bring that up, which would you like to do? Okay, what are you going to let u be? I think you said 4x. What is du dx? What's the derivative of 4x? 4. So that means du equals 4 dx. Is there a 4 in here anywhere besides there? No. So I got to write this as 1/4 du equals dx. Would you agree, Rayanne? So now I got to substitute. I got a 5 out there. I got e of the u. And I have a 1/4 du. Okay? So now I can write this as 5/4 e of the u du. What's the antiderivative of e of the u? It's e of the u. With that 5/4 out front. Plus a c. And so my final answer is 5/4 e to what power, Rayanne? 4x plus c. Okay? Thank you for doing that because it's going to make Isabel's a lot easier. Okay? Isabel, how you doing? Good. Good. How you want to do this? Substitution? Okay. I'm first going to do a couple of things. I'm going to put the 5 out there. Are you okay with that? And I'm going to write e to the negative x squared, and I'm going to write x dx. Because that's all multiplication, right? Okay? So what is u going to be?
Negative x squared.
Negative x squared. Good choice. So what's du dx?
Negative 2x.
Negative 2x. So I don't have a negative 2 in here, do I? So are you okay if I write this? A negative 1/2 du equals x dx? Because I got that right there. That's why I wrote it like that. So I can say, boom, that's going to go right there. So I have 5 e to the u times a negative 1/2 du. You okay with that? Okay, I'm going to bring that out to make that a negative 5/2 e to the u du. Still everything okay? Okay, here's your hard part. What's the antiderivative of e to the u? E to the u. So you got negative 5/2 e to the u plus c. And you're going to write down that's a negative 5/2 e to what?
The negative x squared.
A negative x squared plus c. All right. Michael, ickety ick ick ick. Wouldn't you agree?
Yeah.
It's a lot ickier than hers. Wouldn't you agree?
Yeah.
Right? I'm going to fix it up for you a little bit. All right? Integral symbol, or what you call the thingamajiggy? Squiggly line, okay. E, x to the negative 1. Would you agree with that? This, I'm going to write as x to the negative 2 dx. Do you know where the negative 2 came from? The bottom, that's right. Do you want to do substitution, or do you want to do pattern recognition? Substitution. So what's u going to be?
X to negative 1.
X to the negative what?
Negative 1.
Okay. And what's du dx?
Negative. Negative x to the negative 2.
Look at this. It's here. Except there's no negative sign, is there? So I can write this. I'm going to draw a little arrow. And negative du is equal to x negative 2 dx. Are you all right with that? So this is going to become e to the u negative du. Now that's a negative symbol. It's like a negative 1. Would you agree with that? It bothers me over there. I'll bring it out front because it's a negative 1 here. E to the u du. Okay, here's the tough part. What's the antiderivative of e to the u? So I got negative e to the u plus c. And what is u?
X to negative 1.
Say it again.
X to the negative 1.
Right, could I write that as 1 over x if I wanted to?
Yeah.
Plus c. And I'm done. Jacob, this looks horrid.
A little bit.
Yep. It's not as bad as his, though. Because I got a fraction, don't I? And I got a quantity in the bottom that I can put parentheses around and raise it to the first power. And I'm going to look inside of this, and I'm mentally going to take the derivative. What's the derivative of 1, Jacob? 0. It's gone, isn't it? What's the derivative of e to the x?
E to the x.
E to the x, which is on top. Fraction, a quantity to the first power, and the derivative, and it has the derivative of the bottom is the derivative on top. What am I thinking?
ln of 1 plus e to the
natural log of 1 plus e to the x, evaluated from 0 to 1, right? So I get the natural log of 1 plus e to the first. Would you agree? Jacob?
Yep.
Okay. Minus the natural log. I got to work on my handwriting. 1 plus e to the 0. So that could be written as the natural log of 1 plus e minus the natural log of 2. Right? Because e to the 0 is 1. I had to accept that as an answer. Does everybody see where I get 2? E to the 0 is 1 and 1 plus 1 is 2. Okay? Okay. You might see this as an answer too. The natural log of 1 plus e over 2. I got a feeling the book will write it like that. You can give it to me like that, but they like that. If you didn't see that, you could have done this. I could have said 1 plus e to the x, because that's the most complicated part. That's the part that's inside parentheses, is equal to u. E to the x is equal to du dx. E to the x dx is equal to du. So here's e to the x dx right here. So then I would have 1 over u du, which is the natural log of u, which is the natural log of 1 plus e to the x from 0 to 1. I'm back where I started. Okay? Now, let's say I give you this. I do this stuff on a quiz. So I got a plus sign, I can create two integrals. Logan, you're going to do one of these, and Jack's going to do the other one. Which one do you want to do? What is the antiderivative of e to the x? E to the x. I'm going to have you do one additional thing. You got to put the plus what? Plus c. Right? Because there's no boundaries, right? There's no upper and lower boundary. You can thank him anytime, Jack. Are you going to, is it x to the e? Is that your answer? No, why?
Because e's a constant.
E's a constant. It's over here somewhere. It's 2.71828184590424523 something, right? Because I'm not very good at reading upside down. So, it's a constant. You have to reverse the what? So that's going to be x. To reverse the power rule, this exponent changes to what?
Plus 1, the constant.
So it's e plus 1? And then what do you do?
Divide by e plus 1.
Divide by the new exponent, e plus 1. Or multiply by the reciprocal, correct?
Yeah.
You're done.
Let's see.
C's right here. We did this ahead of time, because this were 5/10 of a point on Monday. Next time it'll be worth 6/10 of a point. Test time, it's worth 7/10 of a point. How? Oh, wow.
When's it going to be worth more than a question?
Next test. Oh, yeah. It'd be better not to do the problem. So if I give you, what's the antiderivative of e to the x? Don't do it, because you might forget the plus c, and you don't lose 1.2 points. All right,
Yeah.
next notes.
You get the answer wrong.
Yes, sir.
How would that work on, like, if someone did, like, if you did a test of all antiderivatives and they forgot every single C?
You'd get negative value, and I can put that on the grade book.
Can you actually?
Oh, yeah. By God, yeah. I have put negative numbers in. That's the first thing I do. Can I put in a negative 2?
What about
Before I
like
taught
the-
calculus, I put negative 10 in there all the time. How do I lose? You got a negative 10 that day. Why? You look like a negative 10, I decided to give you a negative 10. You didn't part your hair correctly. You wore the wrong color shoes. Huh? You didn't have a what? You didn't have a pencil case, and you're required to have a pencil case in the front group.
I really should move.
That was only first try, that requirement.
Oh, okay.
Didn't go to second hour.
Or you sat in the back, or some crazy reason. I don't do that anymore. But I do it with C, because C is like crazy. Yeah? It's free. Look at it. It cost me, I bet you, $200 on that quiz. I got an F. I got 0 out of 10. Never forgot after that. What? F for fix it, yeah. Hi, Michael. Do you like Thin Mints? Michael, I hate Thin Mints. Alrighty. I do. I really hate Thin Mints. My wife loves Thin Mints. So Claire, those Thin Mints I bought were for my wife. Are you awake, Matt?
Yeah.
Okay, you have a question?
No, I'm just reading the formula. The A and the B is really small. Or the A. They have to go on really small.
Oh, this right here?
Yeah.
Yeah, it's tiny, isn't it?
Yeah.
I'm sorry about that.
What's the other one?
You missed another one too. The or.
The what?
Right after the next log, it's really small too. No.
Like that?
Yeah.
Riley! You know how to solve this? Braden, you want to show her how to solve this?
Yeah, you can take the log of both sides.
I'm going to take the natural log. Okay?
Good too.
Is that all right? So if I take the log of both sides, I'll get the ln of 2 equals the ln of 5. Correct?
Yeah.
So that means x is equal... Are you okay with that, Riley?
Yeah, I did actually.
Okay. You knew that?
Yeah.
Okay. And if on a test or quiz you write down the answer as the ln of 5 divided by the ln of 2, I will give you full credit. You're done. So you could go from here to here if you wanted to. But for those people that like their calculator, make sure you round 3 decimal places. Okay? Right, Logan? All right. Riley, what about number 2?
Can you do the log of 15 divided by the log of
You could. That's too much work.
3? Oh,
This is log base 10, right? Log base 10.
yeah.
If they're equal to each other,
X equals 5.
x equals 5, you're done. Okay? Because this has to be 15 also, right? Claire,
Should we put that in exponential?
yeah, I would put an exponential form. So what's your base? 2. What's your exponent? -4. And that's going to equal x, correct? So x is equal to, and you have to give it to me as a fraction. You want me to give you a hint? There's a 1 on top.
Six.
16, perfect. All right. You want to pass on this one? I'll give it to Emily. Because you don't know what's on the next page unless you looked. Okay. Give you a hint. The base is what? 2, right? What's the exponent?
3x plus
What's it equal to? 6. Now, the variable is in the exponent, correct? The only way I can get it down is by doing what? To both sides. Give you a hint, it's like number 1. Because the variable is in the both sides. So are you okay if I write this? Is everybody okay with that step? Because the 3x plus 5 will be in front of the natural log of 2. Destiny, is that okay? Okay, so then what are you going to do?
Subtract the 5,
And then after that?
divide the 3.
So, like that? That one I would require an answer to 2 decimal places because it's more complicated. What's the matter?
2 decimal places? 2 decimal places.
Did I say 2? 3 decimal places. Boy, you do it 2, that's bad news. Okay? Anybody do that yet?
2 decimal places?
3 decimal places.
Negative 0.805.
Okay, that's according to Jacob Schlo. Unless people disagree, that's what the answer is going to be. Is that okay? You got it too? Logan, okay?
Yep.
You're not arguing with him, right?
Nope.
Okay. This, by the way, should say this. But I never remember a formula. Emily, so what do you think you should do here?
Natural log.
Perfect. Okay? We're going to take the derivative, correct? You remember what the derivative of the natural log of y is?
dy dx.
Yep, you got that part. Or y prime, correct? Times, what's the natural log say? I got to have a fraction, correct? Right when I take the derivative? What goes in the bottom? Y. Guess what's on top? Well, it would be dy dx, but we moved it over here, so what's left is 1. Okay? What about this? I'm going to give you a hint. What's the derivative of this? What's the derivative of this? What's the derivative of this? Okay. What's the derivative of this? Almost 7.
Natural log.
Okay. So that means dy dx is equal to the natural log of 7 times what?
7 to the x.
Where'd you get 7 to the x? That's correct. Where'd you get 7 to the x?
In the formula.
Because it's equal to what? Y. Because I multiply both sides to get y, correct? We all get help from our friends. It's expected. Right, Matt? Okay. Matt, would you agree y is 7x? 7 to the x power? Okay. In fact, didn't we on one of the problems when I had y equals, or excuse me, f of x equals 2 to the x. Didn't you guys figure out that the derivative was the ln of 2 times 2 to the x? Wasn't that the first one I did? And then you guys did this one is equal to 3 to the x. Didn't you come up that the derivative was equal to the natural log of 3 times 3 to the x? Am I right? So Matt, I'm going to not give you this one. I'm going to save this for Renee. All right? Because I know it's hard for you to see.
I can see.
Okay, no. I'm going to give you the next one. Okay, you ready?
Yeah.
Okay. F of x equals, how old are you, Matt?
I am 17.
17 to the x power. What's the derivative?
It would be.
Give you a hint, starts with an L.
ln.
Look at the two examples I gave ahead.
Wait. Oh. Oh, 17 times 17.
Perfect. That's exactly correct. Actually, when we have this, I had a lot of people say, this is how I wrote the answer. Natural log of e times e to the x. Right? And they say, are we going to get that marked wrong? And I said, no. But this is the same as what? 1, right? And then that's why you get e to the x. It's the same process, isn't it? So, Renee, I'll write this a little bit bigger because Matt can't see it. Can you see that?
Yeah, I do.
I'm going to write y prime because my hand's getting tired.
Okay.
So what am I going to start out with?
The natural log of 2
Times,
times 2 to the 3x.
times,
3
y3
because the chain.
because of the chain rule. Because you got to take the derivative of this thing. Just like you do with e to the x. So my answer is going to be y prime is 3 natural log of 2 times 2 to the 3x. I like the number in front. Maria. Y prime. What am I going to start out with? Give you a hint, starts with an L. Of what? 3 times what? X squared plus 1 times what? What's the derivative of x squared? What's the derivative of 1? 0. So people said they liked it written like this. Where the 2x came from, the derivative of that. Just like e to the x or e to the x squared or e to the 3x, you're going to leave what you started with because that's y all the time. Again, if I did it like Emily said and took the natural log of y on both sides, I'd have x squared plus 1 times the natural log of 3. Correct? That's where the natural log of 3 is coming from. When I take the derivative, I get 1 over y dy dx. Always, that's the derivative of the natural log of y, equals x squared plus 1 times the natural log, 2x times the natural log of 3. There I go. Got a mental issue. Now I'm going to multiply y by both sides, and I have 2x natural log of 3 times y. And that's where 3, the x squared plus 1 comes from. Logan, you got a tough one. I'll write it a little bit bigger. Y equals the log base 7 of x. Bailey Roscoe had to do this one, and she did it successfully. I was pretty amazed. What do you think you should do? I'm going to give you a hint. Put into a different form. Perfect. Now, here's this exponent variable, right? If I want to get it out of there, how would I do that? It would look like that. Okay. Anything else you want to do yet before we take the derivative? You want y by itself or not?
Yeah.
Okay. You don't have to, but are you okay with that?
Yeah.
Okay. You want y prime or dy dx? I don't care. What's the derivative of the natural log of x? Give you a hint, it's a fraction. 1 over x, perfect. Okay. Are you okay that I write it like this? Or do I need to show you where that came from? Does anybody want me to show you where that came from, or are you okay with that? Because we've done a lot of stuff with fractions, right? I'm going to multiply by 1 over the natural log of 7, right, the reciprocal. This is the same as this. All right? Okay, very good. Kate, you got a harder one. Want me to give you a hint?
Sure.
Y equals log base 3 of x plus 1/2 log base 3 of x minus 7 minus log base 3 of 2. Okay, before you start, do you see where I got that? Okay, I just expanded the logarithms, right? But everybody okay with that? Everybody okay where the half came from? Because there were some questions first period where the half came from. The x minus 7 is being raised to the half power. Okay? All right, so this is kind of like, I know I give you a rule up here, right? And you can follow the rule, but to be honest with you, I never remember it, ever. Okay? But I do rewrite it like this, like how Logan said. 3 to the y equals x. So I'm not going to do the whole thing, but I'm just going to take this one right here and say, all right, I know based on the problem before that I can do that. Are you okay with me? All right. So then Logan took the natural log of both sides. Correct? And then he said get y by itself and divide by the natural log of 3. So the natural log of 3 is on the bottom. Just like the natural log of 7 was on the bottom. So our base here was 7. and it becomes the natural log of 7 on the bottom. So dy dx, what do you suppose the derivative of that is? It's going to be a fraction, right? X ln of 3. Perfect. That's absolutely perfect. Okay? Now, I don't want to have to do that every single time, but this isn't that much different, is it? I'm going to have plus. I'm going to have a fraction here, too, aren't I?
Yeah.
Do you see where the 2 comes from? What else do you know will be down there? Look at this. Look what you got here. Look at this. See if you can carry it on. Three, because that's the base, isn't it? Right? All right. You're 2 for 2. I gotta make it a little bit longer. What else? The x is here. It's down on the bottom, right? X minus 7's on the bottom. Would you agree? What's this up here? 1, because the derivative of x minus 7 is 1. Okay? What's the derivative of this? Too much work. What's different about this term compared to the other two? It's all what? It's a constant. What's the derivative of any constant? 0. So if we had done what you did, we eventually would have to take the derivative of 2, correct? And put it on top. We'd end up putting 0 on top, right? So just, and you're right, it's a constant because all these numbers are constants. And so its derivative is going to be 0. Okay? Everybody okay with that? Nevaeh, you got to figure it out already?
Not super, no.
Okay. You want me to rewrite anything?
We could do 10 to the y equals cosine.
Yeah, you can. And you can always do it this way. You can always do it like that. So what would your next step be?
Take the natural log of both sides.
Right, so you have y times the natural log of 10, and you have the natural log of the cosine of x, correct? I'll put in parentheses. So are you going to divide by the natural log of 10?
Yeah.
Oops. Like that. So now, do you want y prime or dy dx? I don't care.
Y prime.
Y prime. So, natural log of 10 is going to be down here, correct? What else is going to be down here? Take the derivative of that. What?
Or, I can't remember what it is. It's one of our like things that we're supposed to know.
Yep, cosine of x is going to be down here.
Okay.
And what's on top? And if you notice here, x was on the bottom, x minus 7 was on the bottom. The cosine is going to be on the bottom. What's on top? Its derivative. What's the derivative of cosine? Give you a hint, it starts with a negative sign. So your final answer is going to be this. Natural log of 10 is going to be by itself. And what is negative sine over cosine?
Um,
What's sine over cosine? tangent. So it's going to be negative tangent of x. But when you get stuck, coming back to this is not a bad way to do it, and then use your log rules. You have to use natural log because you got to take the derivative at the end. That's why you have to do natural log. Alrighty, last little bit here. How much time do I have? Long time?
25 minutes.
Okay. We're almost done. So now we're reversing. We're going to do the antiderivative. So I'm going to let this, I'm going to let u equals 2 to the x. And if I take the derivative of 2 to the x, what do I get, Jack?
You get, yeah, natural log of 2 times 2 to the x.
2 to the x. Okay? So that means du equals the natural log of 2 times 2 to the x dx. That means 1 over the natural log of 2 du equals 2 to the x dx. So that means now I can write this as 1 over the natural log of 2 du from here. Okay? I can bring out, because it's a constant, this. Okay? What is the antiderivative of 1? U. A lot of people say x. And it would be x if it was dx, but since it's du, it's u. So I get 1 over the natural log of 2 plus, times u plus c. That's times. So what is that? It's 1 over the natural log of 2 times 2 to the x plus c. Ben, you're amazing. You can look up and write at the same time and not look at what you're writing. It's amazing. I can't do that. I always have to put my head down. And then I'd get lost. I put my head up and I go, oh my gosh, I have no idea where I am. I don't know if I'm in math class or English class anymore. Notice, Ben, if I take the derivative of this, what's the derivative of 2 to the x? It's the ln of 2 times 2 to the x, correct? And the ln of 2 times 1 over the ln of 2 will be 1. And it won't be there, and it'll look just like that. And the c will die. Boop, it's gone. Correct? I just had a sad moment today. I didn't tell you this, but Rosie's birthday is March 6th. She'll be 12. That's the sad part. 12. 12 is like older than me. It's like 80-something. She's almost as old as my folks. Next year, she could be. And she still goes like this. But she gets tired quicker when she does that. Well, anyway, it's kind of a sad thing. All right, so this one, I'm going to let 2 to the x, 2x equal u. That exponent. Okay, Ben? So du dx is equal to what? 2. So that means 2 times dx equals du. Right? And I don't have a 2 up here. So I got to write dx is equal to 1/2 du. So now what I have is I have integral symbol, Michael, 2 to the u times 1/2 du. That means I have 1/2 to the u du. You need a bigger pencil, Ben? Do you want a pencil? I got free pencils. I got free ones. You keep them in your pocket? So does your mom ever wash your pants and there's like 3 or 4 pencils inside? You do? Okay. One time my mom washed my pants and there were 3 snakes in my pocket. Live. You know, she always emptied our pockets because she knew there was stuff in them. She didn't want, you know, garbage in there. She wasn't too excited when she pulled out 3 snakes out of my pocket. She was not happy. Alrighty, so I got 1/2 times. What's the antiderivative of 2 to the u?
That is
1 over what? ln of 2 times 2 to the plus c, correct? Or 1 over 2 ln of 2 times 2 to the x plus c. Okay? Oh, I'm going to do a couple more here. Because we're not going to do the next page. And I'll tell you what I'm going to do because I'm not doing the next page. Okay? There's a brief celebration in the back. Alrighty. Logan, this one's yours.
1 over the ln of 3 times 3 to the x.
Perfect. Zach, give you a hint.
Over x not 1
You're close. 1/3. You knew you needed a 3, correct? To get that 3, I got to multiply my answer by 1/3. Okay? So you knew it was there somewhere, right? So this is going to be 1, 3, ln of 3 times 3 to the x plus c. Notice 1, 2, 3 3s, just saying. Yes, sir.
Could you put the 3 to the x on top of the?
You mean like this?
Yeah.
Only the book does that. You know what else the book does?
Yeah, that's my question.
You know what happens then? Students come to me and say, where did that come from? This has an exponent of 1, doesn't it?
Yeah.
The bases are the same. What do you do with the exponents? Yes, ma'am.
Why is if you go 4 lines up from the bottom, you have it.
1, 2, 3, 4. One more?
3 to, no, back one. Other direction. Why is it 3 to the 3x? When the next line we just have 3 to the x.
Oh, it should be 3x. 3x.
We did that with the one before too as well.
I think it was supposed to be a U, not an
With
X.
the
Yeah.
with the 2 to the 2x.
This is a different problem.
Well, no, you did the one with the 2 to the 2x.
The U's. I think.
Oh, there should have been a 2 here.
I think it was supposed to be a U, and then you substitute the 2X in for the U.
Yeah. Sorry.
That's what I was wondering.
We're just disappearing in it.
Yes.
It's maybe not a good time.
Yeah, it is a good
I
time.
was just gonna ask why the number 3 so. I don't know if you can tell.
It's in my blog. I'm the third of my family. I was born on the third day. I have 3 children. The Greeks believed in something called numerology, in which they believed the universe was run by numbers. And so one of the scariest numbers for them, because their measurements weren't as accurate as ours for a given period of time, is they noticed that the circumference of every circle was almost always 3 units longer than the diameter. And so 3 became a very special number. And you find in a lot of religions the number 3, like the Trinity. The equilateral triangle a lot of times is used. If you look at your money, you'll see an equilateral triangle. What's an equilateral triangle? All the sides are the same, but also the height, the median, height, and there's another one, are all the same line. Okay, so 3 is like the most highly regarded number in many cultures. Okay. If I could, I'd change my birthday to March 3rd, but they won't let me do that. Okay. You know,
March 3rd, 1933.
and I've been born March 3rd, 1933, and I'd be a lot older than I am now. People would say, eat a lot because it keeps you well preserved.
There's a 1333.
1333, then I could say,
How about let's go to the future now?
2033.
I would like to retire in 2025 because that's divisible by 3. And
So it's 2022.
it's a perfect square on May 5th, 2025. What? So is 2022, yeah. And plus that has 3 2s in it. But I don't necessarily like 2, but 3 2s is pretty cool. Yes?
Have you seen that movie with Jim Carrey? It's like based on a Stephen King book, I think. It's on Netflix. It's where he like sees a number and everything. You should watch it. I think it's called like.
What's the name of it?
I'll look it up.
Look it up and let me know.
I'll look it up right now.
Isn't there an equilateral triangle on the money?
Yeah, no,
Okay,
no, look.
Mr. Kruger, that's your
Does that mean you're gonna leave them before the AP test?
Yes.
How could you?
I'm going to actually call the AP people up and see if they can have it March 5th.
And after that, they'll be like, peace out, sucker.
I better stop because this is like being recorded. I didn't think of